Anushka Basu. I study in Modern High School for Girls. So I have the TI Inspire calculator, and I've been using it for like 1.5 years now. And I use the calculator for academics. So mainly I use it for for my maths class. But along with that, I also use it for my science subjects like biology and chemistry. And then the calculator TI Inspire, it is very useful and it's very easy to handle. So before this calculator TI Inspire, I had the TI 84 plus CE, and which was also a very good calculator. But after exposure to the TI Inspire, solving sums have become really easier. So some of the exclusive features of TI Inspire are we can graph Voronoi diagrams, which is a part of our IB syllabus, and which is not I cannot draw those in the TI 84 plus CE, that calculator. And then graphing a function in this calculator is very easier because I can just input the function and the graph is like it's readily drawn. But whereas in the TI 84 plus CE, there were like numerous steps to just draw a graph. And doing statistical problems, it is also that are also very efficient because there is a specific feature for of a spreadsheet in the TI Inspire. And the best feature I like about TI Inspire is that we can save documents and have multiple pages open where we can do different questions or parts of the same question. So like during our exams, if there are like multiple parts to a question, then we can simply like open different pages and have solve them separately. Then so initially when I got the TI Inspire last year, I was very confused, like what to use for like specific functions, and thought that along the sum, and even thought that doing the sum manually would be easier for me. But after like attending many workshops and webinars by Texas Instrument, I am able to grasp all the functions and nuances of the calculator. So now I cannot do a complicated math problem like without the TI Inspire. So it's been a really it's this calculator is really helpful.
Hello friends, this is Krish and with me there is my friend Abhay, and today we are going to tell you something about our experience with the TS softwares and the handheld. So let's go. Our experience with the handheld and the TS softwares has been extremely wonderful till now, and we genuinely love the software and the handheld, and we're pretty sure that it's going to be way more amazing in the coming years too. Having the TS softwares and the handheld was really helpful for both of us because we literally use it each and every day when we do the calculations or even in other subjects to do stuff, and we are actually love it to such an extent that I and Abhay actually created a YouTube channel called Crab GDC, through which we actually want to pass on our knowledge about the TS softwares and the handheld to our peers too.
The first question is how do we come to know about the GDC and TI softwares? And the answer to that is that Heritage actually required us to purchase the TI Inspire CX calculator, since it's a pretty useful tool employed by a lot of IB schools around the world. And the calculator does help people in most of the sciences and maths. So the second question is, since when have we been using them? And since Krish and I chose international maths, we started using it in ninth, and we will continue to use it for the diploma program and for tests like the SAT. New concepts and implementing interactive methods of teaching. So I personally loved the TI because it helped me start out with modeling, something that I now really like, and it gave me a base for that concept. Even though it can't do a lot of complex things, it did spark an interest and it did help me build a base in that concept. It's also really great for subject tests like the SAT and ACT, and also good for IGCSE and IB exams.
Hello, a very good afternoon to one and all, and welcome to our today's webinar, which is hosted by the Numerical Analytics Instruments Private Limited. Thank you all for joining with us today, where we are going to focus on the TI, on the features of TI technology that will advance your learning and your engagement. So let me introduce myself first. My name is Jyoti Mewara, and I'm working as an education technology consultant at the Numerical Analytics. So talking about a company, Numerical Analytics are the leading providers of modern education technology and the analytical technology. And we have been around 10 years and working with many educational institutes and the corporate organizations to implement the education technology, business, and the analytical solution. Our head office is in New Delhi and our main office is in Malaysia. Basically, we are the authorized sole distributors of Texas Instrument calculators. That includes scientific calculators, graphing calculators, and the financial calculators across India. Apart from that, we also deal into vernier probes and sensors, which are compatible with the Texas Instruments Inspire graphing calculators, basically. So apart from this education technology, we have our other division of a company, that is the analytical technology, and where we support the research analyst and provide the qualitative and the quantitative research softwares. And if I talk about the partners of numerical analytics are Texas Instruments, eViews, NVivo, and TIPCO. Basically, we have been dealing with many IB and IGCSE schools across India. So some of across India who are the users of Texas Instruments from a very long time. So basically, I can say all the American schools in India, like American School of Bombay, Chennai American Embassy School in Delhi, they are the users of TI since a very long time. Also, the international schools in Hyderabad, Pune, Bangalore are the users of TI. So actually the list is very long. So I can only say some of the schools which are the users of Texas Instruments from a long time. So Kodaikanal International School, we do have Oberoi International School, Calcutta International School, Stonehill, and many more. Okay. So before moving ahead, let's have a quick view. Before starting a session, let's have a quick view on TIA Inspire handhelds. One more thing, we will be having the Q&A session towards the end of the webinar, and also the session is being recorded and we will share the link with all the participants. Okay. So if I talk about the Texas Instruments graphing calculators, it is a powerful tool which is used for learning and better visualizing the concepts in mathematics and as well as in the science subjects. So this is the latest model. This is the latest model of Texas Instrument Inspire family, which is TIA Inspire CX2. So as you can see, its keypad is divided into 3 different zones. So the first zone is the navigate zone, top here, and then below we have the math and the numeric zone, and the down below you can see is the alphanumeric zone. So in all these zones you will find some keys which are computer like, and yes, they function as they function same as they do in the laptops and the PCs. Okay. Apart from that, we do have one of the most important key is this control key. This blue key is very important. Basically, this key is used to access the second function of that particular key. Then we have this escape key, which helps you to come out of the screen. Then we have the step key. This step key is great for navigating between the options. Then this control key, as I said earlier. Then we have shift key and delete key and space bar. So all these keys work similar as they work in the computer keys. Okay. Apart from these keys, many computer like shortcuts are also available. Just like we use control C, control V in our laptops. So in the similar way, we can use these computer-like shortcuts in this TIA Inspire handhelds as well. You can even use Control Z, Control Y, Control X. So all these shortcuts are also applicable on TIA Inspire handhelds. Okay. So in this keypad, apart from that, we do have other keys as well. Like just below the control key, you can see the equal to key. So if I press this control and equal to, so if I press this control and equal to, you will see some relational keys. So all the relational keys are available under this equal to key. Then we have this trig key. So you will find all the trigonometric functions under this single key, that is trig key. Then we have down below the pi key. So all the punctuation symbols, or in the pi key you will find theta, degree, radian, gradient, iota, all these keys. And then you have the punctuation key in the right hand side of the keypad, where all the punctuation symbols are available into it. Then we have a math template key. So this beside this 9 key is the math template key. So this key basically comes up with all the options like matrices, differentiation, exponential, and all these mathematical functions are available easily under this single key, that is math template. Then we have this catalog key. This book-like structure is known as the catalog key. So this key is majorly used if we are not finding any command, or if we don't know where the menu, where it is in the menu option, then we can use this catalog key. And also it provides the syntax for that particular command. Let's say you are going for nsolve. So you can see for nsolve, you need to write the equation, put comma, and write the variable of that particular equation. So this is how you can use the catalog key as well. Okay. So moving ahead, let's explore some activities by two of our trainers, Mrs. Shraddha Nayak and Mr. Jimmy, who will be sharing their valuable insights with us today. So let me welcome our first speaker first, Mrs. Shraddha Nayak. Ms. Shraddha Nayak, and if I talk about her, she's from Oberoi International School, and she is HOD at Oberoi and an IB examiner. She has also taught in American School of Bombay and in international schools in Japan and in Malaysia. Having an experience of over 20 years in integrated math program in MYP, in IGCSE, and IBDP. She provides the instructional leadership and supports the curriculum enrichment using the integration of technology and 21st century skills. Over to you, ma'am.
Thank you. Thank you, Jyoti. I'm going to share my screen now. Right. Yeah. Is it visible?
Yes.
Yeah, okay. Good afternoon, everyone. Okay, really appreciate you joining us for the workshop. It will give you an insight into how you can use the TI Inspire to effectively and and optimally to really demonstrate your understanding of mathematics, right? So since we have a mixed crowd of IGCSE and IB students, and it's possible you are from some other curriculum as well, I have got a mix of activities, a mix of questions to solve, and I hope that you get a good insight into the capabilities of the TI Inspire. Though what I'm going to show you is possibly is more likely to be just the tip of the iceberg. Exploration, since it is math and science are exploratory subjects, the sky is the limit as far as use of TI Inspire is considered. So I'm going to first focus on some features that really let TI Inspire stand out, and as we go through the workshop, through the hour today, you will realize how it is being used. So I'm going to talk about some important, though basic, they really help you in your working of the TI Inspire. So I'm going to talk about how easy it is to add pages and problem sets. And as one of the students in her introduction said, this is such a basic but an important feature, because in an examination, when you have 10 different questions, you can have 10 different problem sets opened on your TI Inspire. So there is no confusion to move from one question to the other. You can go back to the question after you have finished your paper to revise, to review your working, and to see if you need to kind of rework any part. So that in terms is one of an important feature, I would say. The contextual menu. So as we go through the presentation, you will understand how at every different application, it has got its own contextual menu. So the calculator is intuitive. It is built to understand what next you might want to do. So that is why it is called contextual menu, because it works in response to the application you are using. Third, and the most interesting feature, is its dynamic interactivity and visualization, which will be demonstrated through a few of our activities, like data capture and use of sliders. We might not be able to capture everything today, but I think it will sure intrigue your curiosity and help you give a good understanding. So moving on, I want to focus on the calculator functionalities. There are several ones, and as we progress, you will see how they are to be used. So for this one, I want to work and show you what that means. So here, I'm going to open every time we do a new activity or I talk about a new feature, I'm going to use a different problem set. So let me demonstrate. So if you go on to this document and you go down to insert, you have a choice. The choice of opening a problem or a page. If it is a new problem, a different question, then you would go for a problem. Okay. Now here is what I was saying about the applications, right? And we talked about, I said I will show you a few techniques that you can use on the calculator, right? Now, this one, if you see here, since I've opened a new problem, it starts with 3.1. If I were to add a page to this problem, and let me demonstrate. So if I were to add a page, you'll see a plus page right here above the doc, right? Anything with a blue color on the top of the key, you've got to use the control key. So when I press and use the control key, it again asks me, so I can have, let's say I want a graph page here. This 3.1 and 3.2 are linked. Anything that I work on 3.1 can be carried over to 3.2 because they are in the same problem set. The 2.1 is a different problem set because you see the number 2 here. This tells you it is a different problem. Anything that we add, the next page, if I were to add, it would be 3.3, all right? So going back to this one, I want to show you some calculator capabilities. And all questions that you may have, we will take them at the end, or I may, at the end of the session, that might be a good point in our presentation to ask questions. So some of the very basic features, right? Now I'm in a calculator page. So what I get will be a contextual menu. Remember I talked about a contextual menu in the beginning. So here, when I escape, I go back to my original page here. So these are different functions I can use on the calculator page. So let's investigate something in the number. So these are different things that these are numerical applications, all right? And I'm going to show these to you in a short time here. So let's say I want to add 2 fractions, all right? So if I have to add fractions, the fraction is so frequently used in math, it has got its own place here. Okay, there is a here where I'm circling. There you can get to a fraction. So I'm going to control, and I am going to type in 1. Okay, so this is how, and you can use this navigational pad to move on. And I'm going to add a fraction to a fraction here. And I'm going to add 3/5, right? And now I'm going to press enter. Now this is nothing great. Calculators are supposed to be doing this, all right? But what is important, what happens next is I can choose to represent this as a decimal. And when I do that, I can get it back to a decimal. If I'm not happy with the decimal and I still want to go back to my fraction, I can still do that. And it is all in the contextual menu. When I go to number, and you see, and it approximates to fraction, and you press enter and you get your number back. So these are certain things. I'm going to move on to show you a few other things. Okay, if you have, now go to the menu and you go to number, and you will see all these things. I just want to show you how to use these things, these applications here. So let's say I want to find the least common multiple of 4, comma, the comma is right here at the bottom, and 10, right? And I close the bracket and I press enter. There it gives you the least common multiple. In similar way, you can find here, you can go ahead and you can look at other features here. You can find the greatest common divisor, and you can factor. I'll just show you what I mean by factor here. So if I were to factor 100 and I press enter, it gives you in its prime factorization. And this can be important when you have to use these applications for complex problems later on, right? So these are still simple functions that I have used. Now let's get our attention to this degree here, right? As you move into the IBDP, you will be introduced to the radian measure of angles. So angles are measured in different ways. One of them is degree, the other is radian. So you can just click here, and this is really a very cool feature. This is a TI Inspire CX2 feature. You do not have to go back into the settings to change. You can directly change here. And this is so handy because this is kind of, it saves time. It just directly right on your screen, you have the option to change to degree to radian. So if I'm in degree, so now right now I'm in degree, and let me do sine here. So we talked about the trig key. If you go to the trig key here, and if I have a sine, and let's say sine of 30, right? And I press enter, right? I get 0.5, right? Now, if I were to change it to radian, I can do that, radian, and I can go back here, and let's say I want to find cos, and I want to check what it is for pi by 4. So your pi, I'm trying to use keys so that you see where they are located, and you go use the down key, the down navigation key, and you press enter, right? So these are different ways you can do it. Now there is another feature that I want to introduce you to. Let's say I want to find sine inverse, okay? Sine inverse now of 0.5, so it should give you. So let me do 0.5, okay, and press enter. Now, here, because we are in radians, it gives you values in radian, right? And if you want to convert it back, one way would be to go back and change it to degree and then find the sine inverse. But you can also, there is another feature here. If I go into the catalog, so I'm trying to show you different features that you can use. So if you go to the catalog here and you press this changing to degree, right? And you press enter, you get the radian measure converted to a degree, right? Now, let us learn something more, right? This is the basic feature here. Now, let me see what we can do with a different application here, algebra, right? So if you go to algebra here, I will just show you again. So let's say I want to get rid of this. Okay. So while I am demonstrating, I might also tell you certain features which are short keys, or quick methods to get to your working. And let's say I go to menu and we are interested in solving, right? Okay, in numerical solve. This kind of solves your equation, whether it is a linear equation or whether those are logarithmic equations. You use nsolve to solve for x. So I'm going to start with something really, really simple. And let's say it is 2x plus 5. Now, since you're solving and you can only solve an equation, it is important to have an equation. So equal to 0 or equal to, say, -3. Let's say -3, right? Now, since you're solving, you do need to instruct the calculator that you're solving for the variable x, because x is a variable in this equation, all right? And you press enter and it solves. Now, one other wonderful feature of TI Inspire is you don't have to use X. You can use R, you can use M, and it will still solve. But when you use a different variable, so let me demonstrate. Okay, so I'm going to go to menu. Okay, now I don't, let's say I have, so I do escape. I can just, if I have to use the nsolve command again, I don't have to go through the menu. There is one interesting part here that you can do with the TI Inspire. You go up, and when this is highlighted, you can kind of copy it again. All you have to do is, now I want to show you how any other variable can be used. So I'm going to use P instead of X. And let's say I use P, right? But of course, you do need to let the calculator know that your variable now is P and not X. So I'm going to delete that and write P and solve. There you go, right? So this is really cool, because sometimes in your questions, you have different variables used. You do not have to stick to X, okay? Now, let's say we have a quadratic. What happens? Let us solve using a quadratic. And I am going to go to menu again. All the solving tools are available here in the algebra. And let's say I do numerical solve, right? And I'm going to use a quadratic equation right now, a very simple one. And I'm going to use x squared plus x minus 2, okay, minus 2. Again, as I said earlier, since this is an equation, you've got to write it as an equation. So I'm going to write a equal 0, because I want the roots or the x-intercepts. And I need to let the calculator know that the x is the variable I'm interested in. So I'm going to write x here, and I'm going to solve. Now you might wonder, well, this is a quadratic, and this is not a perfect square. So it only gives me one answer, right? It does give you one answer, but there's a way to get around it. So again, since I want to find out the other root, right? I am just going to go to the top, because it is the same question that I am kind of working at, and I'm going to press enter. And now I want to tell the calculator, since I know there is one positive and one negative answer, and this is the positive answer, I'm going to force the calculator to give me the second answer. So I go to this key, the control key, because I am interested in the relational keys now. So I go to control, right? And I use this. This is a powerful command. It says such that, all right? So you solve, I'm instructing the calculator to solve the quadratic such that x, my variable, right, is less than 0. So the less than is right here, and 0. And I press enter, and it gives you the second root, right? So ideally, I wouldn't use nsolve to solve a quadratic. There is a different method you can go about it. I want both answers at the same time, because time is of essence, right? So I'm going to go to my menu and going to show you how to solve for polynomial functions. A quadratic is a polynomial function. So I'm going to go to algebra, and if you see polynomial tools, I find the roots, which are the x-intercepts or the solutions, right? And here I say it is of degree 2. I tell the yes, this is right. I can solve a cubic, I can solve a quadratic, and any other polynomial function. Right now, it is a quadratic, and it is of degree 2. So I'm okay. Now, Ms. Jyoti, she mentioned about moving between fields, right? Navigating. When you have to navigate between fields, the most effective way is to use tab. So I use tab, you see, I'm moving fields, all right? And I say, okay, these are real roots, right? And then it asks me to write the coefficients. The A2, the A1, and the 0 are coefficients, right? So the x squared, this is 1, all right? Again, I'm going to use tab because I'm navigating the fields. So I'm going to use tab. And this is also 1 because it was x squared plus x minus 2. And I use tab and I write -2 because that is the coefficient that is the value of C. And I say, okay, right? So you got this. Now, one distinction here, you will realize that this is solving and this is finding roots. So there is no equal sign required here. And I press enter, and you see, I get both the roots or the solutions as a set. So that is really, so you can use various methods to help you with your working in math. Well, you can also use, so suppose there's a question on sequences. I'm really excited to show you some features, other features. And let's say I want to find a sequence. If I want to find a sequence, right, we go to catalog, right? And since sequence starts with S, all I have to do is press S, and I have to move down, right? I have to move down to the command Q. So if you see sequence here, this tells you exactly what you are expected to do here. This is, pardon me, I'll just go back here. Okay. So if you see here, it tells you exactly what, it instructs you how to go about it. So you need to have your expression, you need to give your variable, you need to give from which term you want to start, and the last term you want to start. These are the number of terms, the low term and the high term, and in steps. So let's try and do this. And let's kind of here, and I click here. So I clicked it twice. So here, if I want to undo, this gives me an opportunity to show you how to go back, right? So I do Control Escape. Okay, so I move back, I undo what I just did. I had 2 sequence commands. I just undid using Control Escape, as you do on your computer. And now I'm looking at an expression. So let's say I'm going to do 2n. I'm going to use n as number of terms, which is very frequently used on sequences and series, and then -1, right? Again, the variable is important. So you got to instruct and say it is n, and I am interested, every command is separated by a comma. So you can say, oh, I'm really interested the first and up to the 6th, all right? And in steps of 1. So if it is steps of 1, you really don't have to write 1. It is by default. So let's say enter, right? Okay. So you get your set of numbers. Now I can store this. What I can do is I can store this, and I'm going to call it odd. I'm going to give it. So this gives me an opportunity to show you how to store variables. So odd, and I press enter. So this list is stored here. Is stored under variables here. If you click here, you might see I've got the odd. It's just the first one that I'm doing. All right. So I am going to go back. All right. And it is stored as odd. So now I can go here and I can say, okay, I want to find the mean. Again, these commands are stored here in the catalog, and they're also stored in the menu applications. We are still in the calculator. We're still not really export the graphing, the lists and spreadsheets, the geometry. We are going to do through the presentation, but If you are on the calculator application, then you can just find mean here, or I can just write, because I know I'm interested in finding the mean, right, of this list here, and I press enter, and I can find the mean. So it is so very convenient when you have stored your results and then you want to really work on those results. So if you're going to use the answers for later parts, this is one of the really cool features where you can, retrieve your outcomes and use them in further questions, right? So this is about the calculator, a very brief introduction on the use of the calculator function application, right? So I'm going to now go to my next one here, right? Yeah, okay. Now let's talk about, so if you were, I want to show you, since I'm going to do a few things here related to graphing, I want to show you how to, again, this is a different problem. I want to draw your attention. This is a different problem because I've started with 4.1. Now this unique feature of TI Inspire allows you to have a note page. So when I open the new problem, all these instructions I have created on a notes page, all right? Now, I do want another page which will link this page to the next page, all right? So what I'm going to do, since I have to add a page, I'm going to, do you see the plus page here? So I'm going to open another page, right? Okay, now we just had a few commands being used on the calculator page. Now the next we are going to kind of explore is the graphing. So I'm going to use the graphing page here, right? You see, this is the graphing page, and the 4.1 and the 4.2 are linked. If I can have, I also have a 4.3 page, all right? And I'm going to show you another page, and let us now go here. And I am going to go back here and add another page. Okay, and I'm going to have a calculator page. So my intention here is to show you how the 4.3 and the 4.2 are linked. And in an effort to demonstrate that, I'm going to show you, okay? So let's now define two functions, all right? I'm going to define a function. So all functions, you can define them. This is one other tool that I'm going to show you. So F, since I think it is already defined, let me just check here. Okay. Yeah. So I'm going to write, you don't have to write f of x or g of x. I'm going to write s of x, right? And I'm going to define s of x. And to define the s of x so that I can use it in multiple places, okay, I'm going to use the control. Now, do you see the colon and the equal to sign? This is how you define. So I'm going to use this. And I'm defining the s of x as being x squared plus x minus 2. Okay, and I define it. Okay. And I have another function. I want to define another function. So here is what I can do. Now I'll just show you what I can do, why defining is really helpful. So what I can do right now is, since it is defined and I click S, do you see it being turning bold? This reminds me that this has already been defined. So what I can do, I can really find S of any value. I can substitute X as 1 and find it. And you find what it is. Instead of having to substitute the value of x as 1 and finding the value, I can just find out another value. So I'm going to do one more to demonstrate what I mean here. So since it is defined, it is bold, and I want to find what is the value of the s function when x is equal to minus 2, and I'm going to add, and it is 0 because these are the roots. These are the roots. So let me show you again here. And let me do 4, right? You might wonder why we get zeros, right? And press enter and you get 18, right? So this is how defining helps, but this is not it. What I can do is I can go here, right? And I can write this here as S of X. So since my S of X is already defined on the calculator application, which is related to this problem, this one problem, right? And I'm going to define this X, right? And I am going to enter. So what I didn't have to rewrite, it has been defined on this page, but the calculator recognizes that it has been defined and responds to the instruction, right? Now, what can I do with this here? All right, we can find, we've already solved this. We know that the roots are 1 and -2. How do we do it on the graph? If I were to use the graph function to find the roots, well, again, this is a contextual menu that is designed to work on the graphing page. So when you click menu, this is its own menu. Since it is on the graph page, it is intuitively built in to understand that since it is graph, you will need to analyze the graph. You'll need to sometimes draw a table or use it for other functions, right? So I'm going to analyze the graph. And what can we do? We can find the zeros, you can find the minimum, you can find the maximum. So I'm going to show a few features, and then we will see something that you can do all of this at one go. So let me show you the zeros. The zeros again are the solutions or the x-intercepts. So when I press 0, of course, this reminds you, suppose in the examination, sometimes they ask you, find the root that is greater than 0, right? So this is a good reminder the calculator gives you that, okay, if you want the root that is greater than 0, then you have to kind of have your bound on the left, since we are going to look at this one. So let me do both here. So this is your lower bound, and it here mentions it. It gives you a prompt that you are kind of defining the lower bound. The root is here. So anywhere to the left of that root, I click and I drag it, and here is my 0, right? And if I want to find the other 0, I can do the same thing again. I can analyze the graph. I find the 0. This time, I will go to the left of the right root here and drag it and to find the other 0, right? Okay, what else can we do? You can go here, you can analyze graph, right? And you can go and find the minimum. This has a minimum, so I'm going to find the minimum. And again, a graph may have several local minima. So this one has just one. Again, it prompts you to identify the lower bound, and you can go here and you can drag and you can find the minimum. Now I'm going to show you something really cool. Now let's say I want to undo this, right? Undoing is really easy. All you have to do is to control escape, right? And I control escape, and I control escape here, right? I do once again because I'm going to show you a very cool feature. So let's say you want to find all the features of this graph at one go. All you have to do is click menu, go to trace, and you graph trace, and you can just move the navigational commands here. Now let me go to the left. It is going to identify all the features for you at one go. So here, when I'm moving, I've used my left to come to the very left. And now I'm using the right navigation button to move to the right. And here is your first 0. And here it directly tells you what it is, right? But it gives you information about all the critical features of this graph in one setting. And I move ahead and I can find the minimum, and it identifies the minimum here. And you have the X and the Y values. And then you keep on going. And then here is your Y-intercept, right? And you have a Y-intercept. You move on, you go on to the next one, you have the 0, right? Now, let's say I want to find what is the value of the function at 2. If I want to do that, all I can do is just click 2 and press enter, and it will give you the value of the function at that point. So this is really a cool and a very helpful method to kind of, if you're running short on time and you have to do several things on the question, this gives you provides you a lot of information. Okay, so I'm going to move on because there's so much to do on this. Of course, you can find the intersection points if you have another graph and stuff like that, and hopefully through our presentations we'll be able to do that. I'm going to now focus on some of the questions on the IB and the IG, which I tried to find a commonality between the two curricula, which will have overlap in these questions. And again, so this is my first example, all right? And since this is new one, I'm going to add another page because I want to show, I want to solve it for you. This is the notes page. I want to open a calculator page. So I open a calculator page, all right? And I use a calculator page, and yeah. And now I'm going to again define. Okay, it gives me an opportunity to show you to define the function again. And since this is a new problem, I can name it again. I can go back and name it the same. I can give it the same notation like f of x or g of x or h of x. So that is the advantage of having different problem sets. Your variables do not get carried on from one problem to the next problem. So you can restart. So I'm going to restart and say, you know, I had used f of x in my presentation earlier, or s of x. So let's say I used f of x here, or I want to show you using, again, I can go Control Escape if I want to undo this, right? Or I can just delete, okay? Since I've used s of x, I'm going to show you s of x and how it does not interfere. So I'm going to use s of x here, okay? And again, for define, I use this, right? And then I'm going to the equation was x squared plus 2x plus 1. So I'm going to write x squared plus 2x plus 1. Okay, and I'm going to enter, so it's done. And the other function was x minus 5, and I'm going to write g of x. I just wanted to show you that this is, I could redefine this as s of x. So g of x here, and I'm going to define it again, and I'm going to write it as x minus 5. Now this is a composite function question, and I define it here and I enter it, right? I'm like going back to the question, right? This is f of x, right? I will just, so this is what I defined was s of x. It doesn't matter, right? So I'm just going to, if you are getting confused, let's write this as s and write this as s here, okay? Now what I want to do is find the value of s of g of minus 1. So you can now, since you have defined this, all I have to do is write s. So you will see it is bold because it has been defined, g, and I just have to input the -1, and I get enter, and I get the value of the composite function as being 35. Okay, so this is really cool. To show you different ways why defining functions is really helpful, because you don't have to redo it several times. It's done once, and you can use that information over and over again. So if you go back here, and it says, now you solve the function again. If this was s, I can go back here, I can make it s, because that is what, so I want to solve for x. So if you go here, right, solving, you use nsolve. I'm going to the algebra thing, I'm going to do numerical solve, and I am going to solve for x. This was 35, was solving for y, and I'm going to do s of g of x, right? And that is equal to, and using my navigational keys here, I'm going to say equals to, which is equals to 0. That is what the question asked. Again, for solving, remember, you've got to define the variable, and the variable here is x, and I solve it. Oh, there's no solution here. So then there is no solution because this didn't, there is no solution at that point, possibly because it was not defined there. Okay, moving on to the next one. Since we are running out of time, I've got so much to demonstrate here, so I'm just going to move on, right? So this is the next question, a very familiar question in the papers for both IG and IB. is a trig function here, and still it is. So what I'm going to do is change this to radians, change this to degree, because my value of the angle is in degrees. And I'm going to open again. If you notice, this is 6.1. I have by design opened another problem set. So I'm going to kind of add another page. Okay. Add another page here, and it is going to be a calculator page. There are several times that I've shown you a calculator page. So maybe there is time that I show you some other features after this. And if there is time, we will come back. So here, since we have to find the angle here, right? And this is the equation to find the area. This is the equation for the area. So let us end solve and see if this works, right? The area is 80. So I'm going to go in here. And it's important that you have changed it to degree. And you go here and you end solve. Right? Here I'm going to solve. And it said 0.5. I'm just trying to look at the diagram here. Yeah, it's 0.5 times the variable times the other side, which was 12. I want to point your attention to this one here, right? This is one side, the other side, and the included angle. So I'm going to write that, right? Multiplied by sine. So the trig key is here, sine, and the angle was 50. Okay, equals to, the equals to is right here, 80, right? Again, we've got to define the variable, which is x, and press enter. Okay, so your side length is 17.4. Now, there are several examples here, but what I want to show you is one really exciting feature, which is called the data capture. Okay, the data capture. Now I'm going to open a new page to show you, but I'm going to first show you the demonstration here. So here is the demonstration that I have for the circle. And the intent here is to see the relationship of the radius with the circumference and the area. So what kind of, as the radius increases, what happens to the circumference, and how does the area also, how are the area and the circumference affected, right? So I'm going to find a relationship. So when you have to explore, this data capture really comes in handy when you have to explore a concept, or you've got to look at data and you've got to find out, you've got to analyze it. So to do that, I'm first going to show you what is the end result. So I'm going to build this activity and I'm going to show you, right? So as I'm doing it here, right, I'm making it smaller, and then the radius changes here, and it becomes bigger, and it becomes bigger and bigger, right? And again, I'm just to capture some more values, I'm going to do that here. Again, the radius of the circle becomes smaller, and now I have got the radius of the circle increasing, and the one in the orange is the circumference, and the one in the green is the area. So, right? So if I'm exploring, I do get an idea. I say, oh, so as the radius changes, right? What is the effect on the circumference? The effect of the circumference is that it is linear. So it is a direct relationship. It is a linear relationship. But as you see the radius changing and you're looking at the area, you see it is not a linear, it is a quadratic. It is a quadratic graph. And you just want to verify. Now here is the added part. Okay, here is an added part where this TI Inspire really shines. You can validate, you can verify your results, which is such an important skill. So if I want to verify here, I have joined these two pages. If you see, I've joined these two pages, and there's not enough time to show everything, but I can now verify this. And to do this, I have to go, so that right now my cursor is on the geometry page, and this is a graph page. So if I want to shift between screens, all I have to do is control tab, and now I'm on this page, right? I'm in the graph. If I want to add any function, I just have to do tab, and I get a line, entry line. I have already preloaded the equations because I know we are going to run out of time. Okay, so you all know that the formula for the circumference is 2 pi r. So if this relationship that I was just investigating, right, is it holds true, then it should really match with the graph here. So I'm going to click this here, and if you see, it just superimposes on my data, on the data values. Let me go to the other one. Let me go to the other one, and I'm going to click in here, and if you see, it really fits well with my data values, right? So this is a really cool feature, and if you have time at the end, I will try and show you how to build the activity. But there was one other feature that I really want to introduce you, because in grade 9 and 11, you may be doing a lot of investigating activities. So this is, I will come back to this if we have time. Okay, one of the other features, for lack of time, this is one important feature I need to talk about, the use of sliders. The use of sliders, so let me go to a page here. I'm going to open up another page because I want to demonstrate the use of sliders. So I go control, document, so it says add a page here, and I'm interested in graphs. I open a graph page, and this was the entry line I was talking about, right? Okay, so if I'm here and I want to find the entry line, one of the ways, there are several ways you can get to the same function, is just to press tab and you get the entry line, right? So the tab is a really, these all important keys, right? One of those is tab. And right, I'm going to kind of write a function here. I'm going to say a very basic standard quadratic equation. And I'm going to say a multiplied by x squared, right, plus b, a, b, c are numerical coefficients. So b multiplied by x plus c. Okay, this is the standard form of a quadratic equation. And I'm going to graph, and I'm going to enter, right? It gives you, it prompts you, it says, okay, these are constants that you have not defined. These are numerical coefficients that you have not defined. So please define them. So I say, okay. And now I have these different, so this helps me understand how the change in the a, b, and c affects the quadratic equation, right? So I'm going to kind of pick this up, okay? So what I can do is control click here, and I can move this up because it is getting in my way, and I can just move it here, okay? I'm going to show you different things that you can do with the slider, okay? All that it does is you can move here, okay? You can move this, and you will see the changes happening to the graph, right? You will see how it affects. So you can see the effect of A on the quadratic equation, okay? Okay, all right. I'm going to show you the next one here. Okay, so this one I'm going to make some changes, okay? So this is a contextual menu again. It responds to your, it understands. So this is called, I call this as an intuitive, tool, because since you are on the slider, it will have tools or functions that are going to work, that are related to the slider. So do you need to move it? Do you need to check the settings? Do you want to minimize? So I'm going to kind of minimize these. Of course, you can go to settings and change the values, right? And to move between the fields, I can use tab. But since I have nothing to change, I'm going to do okay, right? All I want to do is minimize. I want to show you what minimize looks like. Okay, so if it takes a lot of space, this is what you can do, and you can, you can move you can change the values. You can change the values and investigate. Oh, what happens when b changes? When values of b change from -2 to 5 to 5, oh, I see that it really moves in a pattern which is similar to a quadratic equation, because it goes up in a curve and comes down. Okay, the third one that I want to draw your attention to, again, you can click here, I can animate it, right? and it can do, you can focus on what is happening. And right now, it is really clear that the C affects the vertical translation of the graph. It affects how it is vertically placed, So this is how you can investigate, and this is just quadratic. The trig functions, the logarithmic functions, the exponential functions, all you have to write it is in their standard form, and you can kind of investigate. We still have a few minutes, so I want to go back to the data capture, and I can click on this one right now and ask you to stop animate. Okay. One other thing I want to show you on data capture is the trig functions, how we can. So I'm going to kind of show you here. Yeah. Okay. So here, right? So this is a unit circle, and it is in degrees, because I thought most of you might, if you are in grade 9, you may not have been introduced to radians yet, so I've kept it to degrees, right? And I want to see what happens when this one here, right, moves along this circle. How it affects the movement, right? Okay. So I'm going to, all these coordinates, all right, are recorded in the data and statistics page here, in the data and statistics page, and this data is then plot on this graph. So what I'm going to do is I'm going to go here and I'm going to start clean. So I go to menu and I go to data and I clear the data, because I want to show you right from the beginning what happens, right? So here, data capture, and I go to menu, I go to data, and I go to clear the data. Again, I do the same thing here, right? I clear the data because I want you to see right from the start, and I clear the data, right? Yeah, okay. And now, okay, so here, if you see, there's nothing graphed in response. All the values that are graphed here, which are automatically recorded from the movement that I make on this particular page, will be collected here and graphed on this one. So do you see the dynamic visualization of how it is enhanced when you have 3 pages linked to one another, and anything that you do in this page is captured in a page that is linked to this problem set, and then it is displayed on this one. So let's start. Okay, so what I'm going to do is I'm going to combine these pages. If you remember the data capture on the radius example, I had both pages in one go. So all you have to do is do Control-4, and I can have, now this doesn't look like a circle because it's squashed, but doesn't matter. You can kind of change the axes here. You can change the end values, and it is still a circle. It looks squashed because I have 2 pages, all right? So what I want to show you is this is what is called is dynamic movement. So as I move, if you see the changes that take place here, right? And then I can investigate. So if you can see, I can go once more because, all values were not captured. And then I can do it once more here. And I see, oh, so I've got to be slow here. This is not captured here. And okay, let me do it once again. Okay, right? So do you see? So the X coordinate, if you see here, I've created this data and statistics page here, all right, in response to the X and the Y coordinate. If you see the Y coordinate is the one that gives you the sine graph, the blue graph. And when I record it, so this is in change. So let's say I go here and I'm going to record. So if I were to just record the Y coordinate, that is the sine, it would just give you the sine graph, right? But I wanted to show you both, how in one you can capture both, right? So this is just an introduction, and there's so much more. I would stop at this point, and there is so much more to show, but maybe in further workshops, you can join us and find out how you can make your learning fun but also powerful, right? So I will, over to you, Jyoti.
Yeah. Thank you, ma'am. Thank you so much for enlightening our participants with the useful features of TIA Inspire. So moving ahead, moving to the next part of our session, we have our second speaker, Mr. Jimmy, and he is currently an employer of TI Education Technology. He had conducted many workshops and presented conferences and centralized workshops across Asia. And he specializes in applied mathematics and has always had a passion in both teaching and mathematics, and love to explore how technology can be cultivated and implemented into mathematics. Over to you, Jimmy.
Right, thanks, Jyoti.
Yeah.
Right, so hi everyone. So I'm Jimmy. My name is from Singapore. So far, please let me know through the chat window if any issues hearing my voice. Right, it's a bit I'm a bit further away from you all, so I hope everything is clearer. Yeah. At the meantime, let me share my screen. Okay, I'll have to wait for Shraddha to actually stop sharing before I can actually share. So yes, my objective for this webinar, this whole today's session itself, is not only just to show you how to use a calculator, but I hope to actually also just show you what can we do with the calculator, what are the potential use of this calculator, and how can it help you in the future. In a way, I hope I am actually doing something of like a reading your future and trying to let you show you what you can do with the calculator for your future exam questions. Like I will also kind of show you, like in a way, you are in an exam and how do you use a calculator, and also if you have the time, I would like to show you some more exciting features of the calculator that not only do you able to learn concepts from, like what Shraddha mentioned, what she showed through with the data capture, as well as the slider, but also using these tools to help you investigate, and that will probably be very useful, especially for both the IG paper as well as the IB paper, right? Okay, so the main core concept, at least idea for my session now, is that I'm not really focusing too much on how to use the calculator. Like I said that, I'm more of trying to show you in a way, your future. I'm going to actually show you how we use the calculator, how we actually going to use this TIA Inspire to actually do a simple exam question, and also how to actually approach the question. What are the things you can observe from there, right? So yes, yeah. So there's no solution for this case. For here, we are going to cover a topic on correlation regression. Very likely, I don't think anyone have probably seen this topic yet. Right, you're probably new to the curriculum, but it doesn't show you a topic that's in both curriculum. How do you approach this topic, and what are some things you can do? And I hope these are some things that can entice you in using the calculator. Okay, let me just adjust my screen while we set this up. Okay, so over here, it's a single sample. So my focus here is on statistics. Right, we're going to look into a sample exam question, where we have a scientist measuring the temperature at 7 different heights above the sea level, and below are the results. So we're going to use this data, do some study, and of course, not just studying it manually. We're going to use the calculator to help us visualize that. So there'll be some questions going along, and I'll be showing you how we actually do that. So the first thing is the question asks to sketch a scatter diagram. So what I did here was that in this page, this is called the data and statistics page. Just so that you should have an idea, we have these different applications. So this one at the bottom is data and statistics, where you can actually start to draw sketch graphs like the scatter plot here. We'll do some example of like box and whiskers diagram, histogram, or so on, right? So it's really just where we can analyze data and get a visual representation of the data, and to actually better understand what is going on with this set of data, right? Okay, then the thing is, of course, just sketching this, I mean, like, this is the data as statistics page, but we don't have the data yet. So if you have noticed, and I hope you have also keep track of what happened previously, what Shraddha has actually mentioned, the this TI Inspire, one powerful tool is that is variable. You can actually contain variable in the calculator and also use it across the different pages. So over here, what I'm going to do is the next page. I'm going to show you. Oh, sorry. I'm going to create a new page. Sorry, that was actually the next question. I'll create a new page here. So it's Control, Document, if you recall. And I'm going to add a list spreadsheet. So this list spreadsheet is like it's very similar to your Microsoft Excel for those who have used that previously. And the functions that you have used in Microsoft Excel can be also used here as well. And also just to add on as well, things like Control C, Control V, what you've done in your computer, you can also apply it here. All right. So of course, the data is in another page, right? It's on this page here. I have the data with me, so I'm going to key in. What I'm going to do is I'm going to put the A column to be the height above the sea level, and the B column to be the temperature. So I'm going to not only do you just want to just key in the values, right? So I just going to show you like key in the values. You can key in 0, no, 500, and so on, right? But you want to actually, there is a possibility that you may want to use this set of values, this list of numbers, future for the future questions and so on. So we're going to define it as under a term, a word, an alphabet, up to your choice of a preference here. But for convenience and also clarity, I'm going to actually define this as height. A suggestion here normally I would recommend is try not to define as a single alphabet, because it can be easily confused with your other variables if you define in the same page, same problem as well. Okay, so there's height. I'm going to key in the data. 1000, 1500, 2500, 3000, and 5000. Now, in the, of course, in the computer, like what I'm doing now, it's very easy to move up to the top. So now we are at cell A8, right? Let's say I move to cell B1. You can just move. You can just use the mouse and scroll up very easily. But the thing is, you are using this calculator in the exam. So how do we actually navigate faster? One suggestion here is using the Control button. You press Control, and you can explore with 1, 7, 3, and 9. Okay, I just give you a quick one. Control 7 brings me up all the way to the top. Control 1 brings me up all the way to the last cell at the bottom. Control 9 is going up by one page to one page. So it's maybe not too obvious here. Let me go all the way up. First, let's say I want to go to cell 6 to 10 instead. I press Control 3, sorry, 5 to 9, my bad here. And if I go back up one page, Control 9. So it's just a little navigation tool, helps you to navigate around the calculator easily, especially if you're using a calculator during the exam. Right, so quickly I will do this, key in the other list of data as well. Temperature, I just press temp. And you realize that in my values here, just a quick one, the data are not given in a particular pattern, right? It's 0. I mean, it seems like for the height, it does look like it is, but you realize it's 0, 500, 1000, 1005. It doesn't go to 2000, it goes to 2005, and go 3000, and after that, it goes to 5000. So there's not really a pattern for just this set of numbers. If you have a certain pattern to your list of numbers here, you can actually create your pattern here and use sequence what Shraddha mentioned just now, and generate your sequence of numbers for your data, right? So we're not going to show that for now, but this is just something you can consider. And again, hope you can see that this is very similar to the Microsoft Excel. Okay, quickly go key in this data now. All right, so I have my data now. So if you recall in the previous page, I'm not going to show you yet because otherwise the answer is there already. But if you recall in the previous page that in my data and statistics page, there isn't anything in the diagram. So there isn't any points on the diagram, and I can't sketch anything yet. But now if I go to the previous page, you see the points are all there already. So this, the good thing about TI Inspire is that when you store variables within the same problems, you can easily access them. And the calculator will help you to recognize some useful functions and try to give you a prompt on what are the things you want to use. Right. So a scalar diagram is basically you want to plot the data from depending on the two variables here. So over here, for this case, you'll be height against the x-axis is height, the y-axis is temperature. So I click on it, or you can, if you're using a calculator, you can just press tab. Press tab a few times. Okay, good. Once you want to choose height, enter. You see your data will move. So you can even already this interactive view that your data will actually move according to how you want to put in your data, right? And now I'll choose press tab. It goes to the y axis, and I go to temperature. Sorry, yeah, temperature, and enter. So this is my scatter diagram. We're done. We're done for part A. Right. So now, before we go to the next page, let's just show you. Maybe scatter diagram is something too complicated, right? We have not seen this before. No worries. Let's try something else. So I'm going to Control Z. Oh, sorry, Control Z is undo in the computer, right? You can do that if you want to, like Control Z, or like what Shraddha mentioned, Control Escape. You can do that as well. Okay, both of them are the same thing here. So I'm just going to use show you instead of the scatter diagram. Okay, we already done that. We'll go to that in a while. I want to just do some other diagram. So let's say we have height here, right? And I want to, let's say, view something else. So there's one very powerful, in I click from just want to highlight. When you use the computer, usually when you click any if any functions that you want to access on, you left click onto your mouse or your touchpad, and you actually choose the thing and open up that file, right? So the left click button on the calculator is actually this little mini button in the middle of the touchpad here. But in the mouse or using a computer, there's also a right click for your mouse. So the right click button, I mean, of course, like now I'm using my mouse, I can just right click like that. Right? How do we do it in the calculator? If you have the calculator, Control Menu. Right, you must be sure where your cursor is. So let's say my cursor is somewhere in the middle here. Control Menu. It's the same thing as what I did just now. Just a right click. So sometimes right click can be a very quick method to access those functions that you want to quickly access. Right click is like it's the same way as how you you access in your computer. You want to right click because maybe you want to copy a file or something like that. Right. So I'm going to show you different plots you have. Like for example, right, I can draw the box and whiskers diagram here. Then if let's say you don't like that, you want to change histogram. Okay, maybe your histogram is, of course, this is just with frequency 1, so of course you don't have the nice histogram view, yeah. But over here, you can change the scale. Like for example, the bin size, right? I can change the bin size of everybody. Let's say maybe 5,000. Sorry, 500. 5,000 is a bit too big. Alignment, I don't know. Let's say maybe 500. Okay. You can change the size of your histogram as well. These are some things you can do. So it really depends on the question. For our particular question, we want to have a scatter diagram, so it's a bit different. Okay, we don't cover this here. This is probably out of syllabus here. But yes, different plots as well. So even going further, just to let you know, I'm not sure if you noticed, different application. When I talk about application, I'm saying there's a calculator application, the graph application, and so on. Different application has customized menu, like what Shraddha mentioned just now. So for this case, for data and statistics, we have your plot type, your plot properties. You want to analyze, you want to add a movable line to do some analysis. You want to change, you want to zoom in also. We can even insert a slider here, right? What we just learned maybe 15 minutes ago. You can even insert a slider here as well, right? So this is all the things we can do. Feel free to explore this one here once you get the calculator, right? Okay, let's quickly just go back here, be easier. Right, so mainly just to show you this scatter diagram. And I'm going to go back to this scatter diagram in a while also, right? So let's look at something else first. So the next part in this question here is, okay, I didn't really change the format of the question. Probably maybe just the context of the question only. But these are literally sample questions from the exam. So you will probably be asked to find these values as well. Like for this case here, find the mean height and as well as find the mean temperature. Okay, so I mean, one way you can do is that in this page, you really have the height and temperature. right? So you can of course do everything here. But what I want to show you is that you can actually call back your functions, call back your variables that you have already defined previously. Like for this case, I have a look at my previous list and spreadsheet. I have temperatures a bit, maybe too cluttered, right? I want to probably redo everything on the fresh page, but I don't want to remove my variables height and temperature. So over here, what I do is I actually call them back out. This variable button, basically what it does is that you can either store your variable button or you can call past variables that you have previously defined. Well, I'm going to call, let's say height. Let's work with height first. See, once you call them out, the values are all there. And you can change accordingly as well if you want to. Okay, but not for this. I'm not going to do that. And what I'm going to do next is find the mean height. So to do that, we press Menu, Statistics, Set Calculation, and one variable statistics. Okay, focusing on just one variable statistics. There's also a lot of the rest which we will explore later. Not all, but at least some of them. So there's the number of lists. Okay, one. We only have one list to work on. And which list are you talking about? So if you recall, we can press Tab to navigate between the different options, right? But just to let you know, if you have a little arrow at the side, it means that you can, like for example, if on your computer you got this drop-down box. So this is something like a drop-down box as well. You can press right. Okay, sorry, let me try again. Press right to put in the variable that you have defined previously. So let me go back up. Right, and my X list now is height, so I will use height. And I want to display my data over here. Okay, I will come to it. What do you mean by data? I will explain in a while. I will display my data on the column C. Yeah. So over here, I'm going to adjust this screen for a while for convenient, for easier viewing. You can see that from this list of data, I can get all these things, all these statistics values that we can actually use for future calculations. Okay, there's a few things that probably you may seen before. This is actually the mean, which is the answer for this question, the mean height. We have other things like, for example, the first quartile, the third quartile, the median, right? These are few statistics tools the statistics values that you want to probably use when you do some calculation, right? So just take note of that. But yes, with this function here lets you pull out all the statistics for one variable data. So we do the same thing. There's a quick one here. Right, I'm going to go to the next cell and pull out temperature. Okay, of course you don't have to pull out. So if you realize, okay, let me just do a control escape, go back. You don't have to pull it out as well. Just click an empty cell. You have to click an empty cell first. Click an empty cell, menu, statistics, set calculation, one variable statistics here. Okay. And I press right twice. I can just click temperature. The calculator already know this list and you already stored it in your calculator. So you don't have to call out the whole list to see the list again. If let's say you know what you are looking for, right? Okay, frequency is 1, everything will remain the same. You can press enter, you can press tab such that it goes to enter. Okay, I mean, and just press enter. Right, so you have, this is the data for your temperature. So over here, temperature, the mean temperature is 2.357. Right? Okay, then of course, what if, for example, what if I have a next question that requires me to find the mean height and the mean temperature? I mean, one way you can do is that, oh, okay, the mean temperature is 2.357, the mean height is 1928.57. No, you can memorize the number. But in the calculator, what it does is that even though by doing this whole thing, the calculator will automatically store the variables for you. Okay. What do I mean? I will come to it in a short while, but you will see that I will actually use these values that I've calculated in my next part of the question. Okay, think about it for a while. Okay, now let us just draw the line of best fit for your scalar diagram. So basically, let me just go quickly to the scalar diagram. This scalar diagram, there's draw one line such that it's like a line that best fits, that connects all these points. It's almost impossible to make sure that it connect all of them. But a line here, slope, such that it kind of at least best fit all the make those points as close as possible to the line, right? We want to do that. And over here, I want to show you, rather than using the data and statistics option to actually find, we actually use list, another option, which is graph. And what I'm going to do now, I'm going to actually sketch the scatter plot. So again, I'm not going to go through too detail in how to do that. But what I'm going to do is change these to a scatter plot, pull out my variables, height is X, temperature is Y, enter, nothing. Sorry. Menu, window, zoom data. So this is my scatter plot. And to draw a line of best fit over here, so how do we actually draw the line in best fit? Of course, you can actually just, let me change back to functions. No, try to guess equation itself. But the good thing about the TI Inspire is that, I mean, this is more for the IB, okay, not so much for the IG, but you can actually find out your regression line, which is the line of best fit. Quickly to show you how it's done. I go back to my list and spreadsheet with two data, do a statistic for now both variables, like a linear regression here, height, temperature, and the equation of my line of best fit or the regression line is going to be saved in F1. So over here, the equation of this line of best fit will be y equals to negative 0.00637 or GSF, x plus 14.6. Yeah. So from here, this question, if I press tab, you realize that now it's F2. If I go up, the line of best is already stored for you. Just need to check this option, or you can just press enter, the line will be there. Now, how do we plot the mean point? Okay, I'm already been run out of time here, so I'm going to go through quickly. This is a new feature for the TI Inspire CX2. So those with the older calculator, you will not have this. You can press P, and you actually quickly put a point onto the calculator, or put a point, or you can actually put a point on the graph, anywhere on the graph, and key in the coordinates. What I'm going to do is I'm going to just use the coordinates and key in the values. What values? See, now my calculator actually store all the data from previous. X is, the data 1 is actually height. Oops. Sorry, let me repeat. Oh, it should be, I think it should be this one. Sorry, give me a minute. I'm just going to key in the data of my, from my previous question, and you realize that this point here, oops, sorry. See, I can actually move the graph if you notice, but this particular point is really the mean point on my scatter diagram, because it's my mean of my height and the mean of my temperature. Okay, that's that. And also, they ask us to actually determine the temperature, the line of best fit. Use the line of best fit to determine the temperature at 4,000 meters. So what you can do is you can actually, a quick one, since you are here. Sorry, I'm going to use P again, use point. And this time, this point here, if you notice on my diagram, I can put anywhere, or I can put somewhere on the line of best fit. And then just change the double click. Or if it's too cluttered, you can move it around. Move your cursor around the x-axis, double click this into editor box and change this to 4,000. Right? The answer is negative 10.8. Or the last option here, which I actually want to show you over here, but due to time constraint, we'll do it all in the same diagram there. Last option is to create a calculator page. We know that your equation of your best fit is under the function f1, right? It's bold, right? So it's already been defined. Bracket 4,000. Right, that's the answer. So negative 10.83, negative 10.8. Okay, unfortunately, due to time constraint, I will not be able to go too much in detail, but I just want to show you just a probably I just need maybe a few seconds, probably let's say 30 seconds, just to show you another application, which is the geometry application. I think someone in the chat box actually asked about circles and so on. We actually can do that as well. You can use the geometry application here to do investigation, like for example, minor and major arc. You can play around to see what becomes a minor arc, what becomes a major arc. We can have finding the angles between which is your minor and major arc as well. In this angle is basically this angle here, and playing around with your diagram, you can also try to see what happens to your angle. And over here also, with this file that we have, we can actually learn few circular properties that you will learn throughout your course as well. Right? For example, angle from the same segment, angle from in the center compared to the segment, what's the ratio, things like that. Okay, due to time constraint, unfortunately, I will not be able to go in detail on this, but this is little example on how we use the geometry app to do some circles, and not just circles, but also angles of the circles, angular properties of the circle, and how do we actually see that some of the angular properties, how do we actually visualize those properties as well, right? Okay, so that's all I have for me. Apologize if I did the last few minutes for going a bit too fast, but I thought I want to at least show you some of the potential power of this TI Inspire and how it can be useful when you actually use it physically in the exam. Right, I'll pass my time over back to Jyoti.
Thank you, Jimmy. Thank you for your interactive session to showing the features, what all students can do using the TI Inspire. So we can have the questions now. If you have any queries related to the today's session, you can write in the chat box. We have Shraddha ma'am and Jimmy with us.
We hope that y'all are able to see not only that the graphing calculator is a tool just to answer questions in the exam, to do basic calculations. And of course, I mean, not just also probably advanced tool where we can do graphs. In your curriculum, you will have to do investigation. You probably have to do modeling as well. So we hope to show you that some of the features here will be able to help you analyze some question. Will be able to help you to model problems and do some analysis from there. Right. So I hope this is something insightful, and that there'll be something attractive for your side. Yeah. I mean, there's some comments from me.
Do we have any more questions? Okay, so we are nearly towards the end of our webinar. If you need any more information or you want to contact us to get help regarding your technology, you can reach us at the given number, or you can even mail us at the given mail ID at the student support numericalanalytics.com, or either you can write us at educatorsupport@numericalanalytics.com. And I thank you, Mr. Jimmy and Ms. Shraddha Nayak. Thank you for being here with us today.
Yeah, it was a real pleasure.
Yeah, thank you for inviting me, and I hope everybody stays safe, take care, and yeah, hopefully you're able to use this potential powerful calculator for your future use, future education.
And I thank you all for joining for our today's session. Thank you so much.
Oh, there was one question about the recording. Yeah. Yes, the recording will be made available.
Yes, we will mail it in 2 to 3 working days. We'll definitely mail you. And even we will post this recording on our YouTube channel, that is Numerical Analytics. You can also view the recording over there on YouTube.